Second video, we're going to look at actually analysing simple harmonic motion, trying to think about what's actually happening. And we're going to think about pendulums to start with. So if you've got your own pendulum, you might want to look at it in a minute. Maybe pause this and go and get something that you can swing back and forth. You probably can do it in your head as well, but sometimes having something tangible can actually help. So we could start off by looking at springs and masses oscillating up and down, but I'm going to suggest pendulums for today. A couple of little things about pendulums, because this used to worry me when it was first introduced. When we're talking about displacement of a pendulum, we ignore the fact that it's following this slight arc. What we do is we just assume that if you take the rest position to be, say, there, the displacement is just how far it's moved in the x direction. And actually, this is why pendulums only observe simple harmonic motion if it's going under a small angle. As soon as you have large angle oscillations, actually the restoring force becomes not proportional to that displacement. So there'll be more on that a little bit later on. But anyway, just so you know, for the displacement of a pendulum, we just assume it moving horizontally to one side. Okay, so what you might want to do is draw for yourself something like I've got in my picture here. So I've taken my pendulum, I've displaced it over to one side, and I'm going to say that this side is a positive displacement. It's arbitrary, but I'm deciding that that's positive. I'm going to let go of it. It's going to swing through the equilibrium or rest position, somewhere in the middle. Well, not somewhere in the middle, in the middle. And then it goes past that rest position, and we then go over to negative displacements. And that's just a convention that we have decided to agree upon, or I have decided for you that you're going to agree upon. So what I want you to do, taking these as our ground rules, moving off to the left here is a positive displacement, I want you to just basically think through the following. So I want you to get your diagram, and I want you to basically say or indicate on it in a sensible way where the greatest displacement is, where it's going fastest, or where the greatest velocity is. And actually, if we're talking about velocities, you might want to think about the sense of that velocity. Which direction? Is it a positive or a negative velocity? And relate that to what the displacement is. What I mean by that is, if you're moving towards a negative direction and you've already decided that this is a positive displacement, moving that way would be a negative velocity. Or would it? Yes, it would. Suddenly confused myself for a second. Right, but I'm not going to pause and restart. But I am going to choke. Sorry, everyone. Okay. Next thing is to indicate where the acceleration is the greatest. And again, what direction are the velocities and the accelerations? You probably could get that from your definition of simple harmonic motion, because you know that the acceleration is proportional to the displacement. But it's still worth marking on your diagram. So pause this for a few minutes and draw something out and see what you come up with. Welcome back. Assuming you did pause. I'm guessing many of you didn't actually pause then. Okay, so this is what I came up with. I'm using S for displacement. That's the convention. It's simpler than writing the whole thing out. I've got my positive direction over here. So when it's over to one side, we call that S max. And I've put a positive sign here, a plus sign, just to say this is a positive displacement. It goes through the minimum displacement. And I had a bit of an internal debate here whether to call that S min or just really 0. And then it goes to a maximum negative displacement. Now, for everything that we do, for the next sort of couple of lessons, we're going to assume this motion is not damped. So these two things will be equal in magnitude, just opposite sense. Okay, so that's our starting point, and I sort of gave you that already. So what about velocities then? So I'll go on to the next slide to look at velocities. Here we go. So I've left up here S max, S min, and minus S max. I know you need to think where to apply these things. So, I mean, it's not too tricky, especially if you start with thinking about the minimums. So, it starts oscillating, displace it to one side, let go of it. As it comes up to one side, eventually it comes to a stop and then comes back down towards the centre. So at the extremes, that's where it's slowest. In fact, it's not slowest, it's stopped because it has to change direction. So what we can do is we can mark on here that we are, we have a minimum velocity at this extreme. So the velocity is 0 when the displacement's at a maximum, and it's also 0 when it's over the other side here. But now you've got to think what's happening in the middle. And I mean, it's pretty obvious. It's going fastest when it's in the middle. So we've got the maximum velocity. And I probably gave you too much of a clue a minute ago about this. But, right, if we start off with a positive displacement, we let go of it, it starts heading in this direction. It's heading towards the negative side. And when it gets to the centre, it has the maximum negative velocity. It goes past the centre, it still has a negative velocity, but the magnitude of it is decreasing until it reaches 0, and then it increases again, but heading towards the positive side. So going this way, it's all positive velocities. So we have plus Vmax here. This is probably the bit that you need to sort of really soak up, because it's going to help you when you come to look at graphs of displacement against time and velocity against time, what's happening at each stage. Okay, so we got that bit. What about the next bit? Okay, accelerations. So I've done this for quite a few years, and people seem to find a bit of a challenge with the accelerations. I think the reason they find it challenging is you feel like if something's got a large acceleration, it should be moving, but it's not really the case, is it? It's about the rate of change of the velocity. Now, I think you can do it intuitively just by looking at what's happening, but it does help sometimes to go back to the expression A is proportional to minus x. Although I've been using S for displacement here, it doesn't really matter for this. So the bigger the displacement gets, the bigger the acceleration gets. But that also means that the smaller the displacement gets, the smaller the acceleration gets. And in fact, when the displacement is 0, because it's directly proportional, the acceleration is going to be 0. So we end up with the minimum acceleration at the middle. Now, I think a slightly more intuitive way of thinking about that is that at this point, there is no longer any force trying to return it to the middle because it's at the middle. And if there's no force, it's not accelerating. So the acceleration is at a minimum, or the acceleration is probably better to say 0 at the equilibrium position. As you move away from the equilibrium position, the returning or restoring force gets bigger, and because of Newton's second law, the acceleration gets bigger. So we get a maximum acceleration, but we've got to decide the sense of it. So as we move over to this positive side here, let's say on this return journey up here, the restoring force is slowing it down. It's trying to sort of accelerate it in that direction. And in the initial situation, the acceleration again was increasing the velocity and making the velocity head that way. It was accelerating that. Okay, so that's telling us something. That's telling us that the acceleration is making it move towards, or increase in velocity towards the negative side. So this has the maximum negative acceleration when it's over to this side. Has the maximum positive acceleration when it's over the other side. Now I've drawn all over that, so it looks a little bit of a mess. So I think your job now is to take this diagram and maybe annotate it with what's going on. The fact that I've referred to things as minimums where you could be saying 0. You might want to annotate on about, what might you want to do? About how this relates to our expression for simple harmonic motion, F equals minus kx, or A is proportional to minus x. You could do a similar thing to this. I doubt many of you have got springs and masses at home, but you could probably use that PhET animation from the other day, or you could just basically imagine it. We could do a very similar thing for, here we go, a spring. Sorry about the awful drawing of a spring, with a mass that's moving up and down. And you could indicate where the maximum velocity is going to be, the maximum acceleration, whether it's positive and whether it's negative. And that's a task I'll leave you to do, and I'll leave this here. That doesn't make sense. That's it for this bit of the video. Thanks everyone. I will now try and pause it.